In this question, we have to find the Young's modulus of a brass rod of diameter 25 mm and length 250 mm, which is subjected to a tensile load of 50 kN when the extension of the rod is equal to 0.3 mm. This is a question of stress and strains where we have to find the Young's modulus of the brass rod, and we are given with the diameter 25 mm and length 250 mm. And it is also given that when we apply a 50 kN of load to this rod, there is an extension of 0.3 mm. Now you find the Young's modulus of the brass rod. So let us solve this question. In this numerical, we have a brass rod, and some of the data regarding the brass rod is given that when a load is applied, 50 kN of load is applied, there is extension in the bar of 0.3 mm, and the original length of the bar is given 250 mm. Also the dia of the bar is given 25 mm, and we have to calculate the modulus of elasticity of the brass rod, right? So we have, suppose we have a brass rod and a force is applied 50 kN, and it has length 250 mm and dia is also given. This is circular rod and dia is given 25 mm, and we have to calculate, and also due to this load the extension in the wire, increase in length of the wire, delta L is also given, delta L, and that is given is 0.3 mm. We have to calculate the modulus of elasticity of this material. There will be some tensile stresses developed in the material, and we have to calculate the modulus of elasticity, right? We have some ready-made formulas for simple stresses, that stress is load upon area and change in length. Change in length is PL upon AE. P is the load, L is the length, A is the area of the cross section, and E is the modulus of elasticity. We can apply this formula and directly we can obtain the modulus of elasticity. So we have delta L will be equal to PL upon AE. So this implies E will be equal to PL upon A delta L. And because this is circular, so we can write PL upon pi by 4 d square into delta L, change in length, and that will be equal to 4 PL upon pi d square multiplied delta L. So this is our modulus of elasticity. By this we can find out the modulus of elasticity of this material, brass. This is brass rod. Right? So put the values and get the value of E. So E will be equal to 4 P, load is 50,000. So 50 multiplied by 1000. L is the length, 250 mm. So you will get 250 multiplied by 10 की power minus 3, 10 to power minus 3 meters. We are converting it to meters, divided by pi d square is 25 mm. So it is also mm. You can write 0.025. So this will be 0.025 meters. So I am converting it into meters. So 0.025 multiplied square of this, and delta L is 0.3 mm. So you can write 0.3 multiplied 10 to the power minus 3. So it is very basic simple calculation. You can solve using calculator. Take your time and solve it, and you will finally you will get the value as 84 multiply 10 to power 9 pascals. The answer will come in Pascal, right? Answer will come in Pascal. You can solve it and you can get the answer. Now, what is 10 to power 9? This is gigapascal. So we can write E will be equal to 84.8 gigapascal. Mostly the value of modulus elasticity is around, for brass it is around 100 gigapascal. So it seems to be a good value, 84.8 gigapascal. So this is the answer of our question.